Right, let's talk about DXing from a mid-terrace house. Now, I was quite lucky here. I was lucky enough to have a 12-meter tall mast in the back garden with a Moxon beam on it, and that was absolutely brilliant. And I could work into the States any day of the week, even when conditions were terrible. Unfortunately, that had to come down. We were looking at moving house, so I had to pull it down in preparation for moving house. And unfortunately, COVID kicked in, plans changed, and we never actually moved house. So I'm now mastless. So I want to get back on 20 meters, and I'm trying to figure out the best way of doing it. Now, I've tried quarter wave verticals and end-fed half-wave verticals here, and as much as they've worked really well when out portable, they've been really rubbish here. And I think the problem is I'm on a housing estate. I've got there's a big trading estate that way and over that way, so warehouse buildings all around, and houses, metal shed. There's just too much clutter on the ground, which I think is causing a load of attenuation for my signal. So I think what I need to do is get the antenna above roof height. Now, the problem with that is if you're using something like a quarter wave vertical, you need a ground radial system or some kind of elevated radial system, which gets a bit tricky. But end-fed half waves aren't quite so fussy, and if you don't provide a radial for it, it'll actually use the coax as a counterpoise. So I'm wondering if I can get my end-fed half wave up nice and high above the ground, then I might get some decent results. So I'm thinking we need to look into this. And I did a bit of modelling on MMANA, which is some modelling software on the, it's free to download. I'm not going to go into the how I modelled it. There's plenty of videos on that, and I think Callum DX Commander did some good videos, so I don't need to reinvent the wheel. But let's look into that, because some people say you need to get it at least a half a wavelength up in the air in order to get decent low angle takeoff with the end-fed half wave. And some people also say if you lift it up just a little bit off the ground but not enough, then its performance will actually be worse, and you'll end up shooting most of your radiation into space. So let's look at my models and see what we came up with. So I've got a chart here, and the way this is laid out, you've got your gain on the left hand side here. Each coloured line represents a different height above the ground. So this bottom dark blue one is ground mounted. I did one at 2 meters above ground level, the theory being that I've got a 12 meter high spider beam mast. So if I mounted end-fed half wave for 20 meters on that, then that's going to put my feed point 2 meters above the ground. And by the way, all of these were modelled for 20 meters, which is the band we're looking at. I did 8 meters above ground level, so that's the feed point at 8 meters above ground level. So we're talking about an 18 meter mast, which I think is the biggest I'm going to get away with here, safely anyway. Out of curiosity, I also modelled it on a 22 meter mast because I've got the 22 meter spider beam. I don't think realistically there's no way I'm going to get that up safely here, but I modelled it just out of curiosity. So that put your feed point at 12 meters above ground level. So this is just over, very slightly over half a wavelength above ground level. And then just for fun, this grey line up here, I also modelled it at 20 meters above ground level. Now, that is absolutely ridiculous. We're never going to be able to do that, or at least not here, because you're talking a 30 meter tall mast. There's no way I'm putting that up in a mid-terrace house. And by the way, these if you can see these little numbers here, I've got 5, 10, 15, 20, 25 and 30. That's your different angles of takeoff. So I've modelled this at several angles of takeoff. So let's for now, let's just look at the two we're interested in, which realistically, I think the biggest I can get away with is an 18-metre mast. So we're mounting this 8 metre with feed point 8 metres above the ground on an 18-metre spider beam mast, which is achievable. And this is our baseline, which is EFHW halfway ground mounted. So at 5 degrees off the horizon, ground mounted, we're getting -5 dB. If I move this up onto an 18-metre mast, that's -2 dB. So we're talking a 3 dB increase in your radiation pattern or your signal at 5 degrees off the horizon, which is your real low DX. So initial reaction, this is looking good. Similar thing for 10 degrees above the ground, and 10 degrees off the horizon, and the gap's narrowing down, but you're still a dB better at 15 degrees above the horizon. So your real low DX is going to be coming in sort of 5 to 15 degrees above the horizon. This is what I'm interested in, this first half of the graph here. And initial reaction, it's actually looking really good. Now you get up to 20 degrees and 25 degrees above the horizon, and the elevated EFHW half wave actually isn't as good, and then it picks up again here at your high angle at 30 degrees, which so this sort of 25-30 degrees is going to be your real sort of high angle regional sort of up to 1,000 miles stuff. So first reaction is looking good. I mean, obviously I'd love to get it a full wavelength above the ground, and then you're doing brilliantly all the way across, or even on my 22-metre mast. But that, like I say, we have to be a little bit realistic here. I'm in a mid-terrace house, and I don't have a lot of space, and 18 metres, if that falls down, it is going to land in the neighbour's garden. So I need to be very careful how I do this, and need to work it out safely. But I've looked at it. I think we can do it safely. So I've already ordered the mast. I've actually ordered the DX Commander 18-metre mast, which I've got. It's downstairs. I've got to build up the clamps for it. So you get your Callum supplies these clamps with it, and rubber which you measure to go around the mast, so that stops the mast collapsing on itself. So I've started making these up. So that's in progress at the moment. So once I get those made up, I've got the guy ropes down there which I need to measure out and cut, and need my anchor points, which I'm actually going to drill a hole into the wall of the house and use metal eyelets, because I want something really really secure to hold it up. I don't want this falling down, just from a safety perspective. So there's a couple of logistical things to figure out. I'm working on the grounding system here at the moment, because I want to make sure this is properly grounded. There'll be separate videos on my grounding system. So once I've got the grounding sorted, we'll get this up in the air and see how we get on. But looking at my results here, assuming my modelling's accurate, I think this is going to be really good.